Yes, I'm telling you, it's awesome. I've taught 4th grade. I don't teach 4th grade this year. Making some videos for you guys, but so bear with me as I try to teach these lessons. My goodness, this is some pretty challenging stuff you guys are doing. We have lesson 4.6. Yes, cruising through chapter 4. If you recall our last lesson, we did some estimating, right, with quotients and stuff, and that was a pretty challenging lesson too. Learning how to look at some compatible numbers so that we could just estimate. Here you can look at our topic and you can see clearly it says division and the distributive property. Oh no, I know, distributive property, what is that? Right? This is such an important property to understand. So we're going to be focusing on that because when you look at the essential question, you can see it says, how can you, that's right, you awesome 4th graders, how can you use the blah, 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 blah. How can you use the distributive property to find quotients? Now let's remind ourselves that a quotient, right? The answer to a division problem. That's what a quotient is. Okay, I don't know where that voice came from. How strange. Now, we can't do any of this unless we, there's no unlock the problem. This is like a hands-on activity. Look at the purple hands over here. Hello. Yeah, okay. Mr. Wara, please. Okay, so we have a hands-on activity and it does say investigate. Okay. Cool. We have some materials. All right. So if you're here, I don't know, at home, in the classroom, wherever you might be, out there, you might want to get some coloring pencils and some grid paper in order to work with me on this. Some of you have this actually in your workbook, but let's get started. It says you can use the distributive property to break apart numbers to make them easier to divide. Okay, so again, repeating, we're going to use this property, the distributive property, we're going to break apart. Key words, okay? Break apart numbers to make them easier to divide. Now it says the distributive property of division says that dividing a sum by a number is the same as dividing each add-in by the number and then adding the quotients. Ooh, okay, that seems kind of crazy. I don't know. We're saying that if you take a sum and we divide that sum by a number, that's the same as dividing each add-in by the number and then adding the quotients. So let's go ahead and do this little hands-on activity here and see if that doesn't help you make more sense. So A says outline a rectangle on a grid to model 69 divided by 3. Shade columns of 3 until you have 69 squares. And then it's going to ask us how many groups of 3 can you make? Well, let's go ahead and do that. If we have columns of 3, kind of suggests to me that we need to make a column here going down because I think of a column going up and down. So here's my column of 3. 1, 2, 3. And then it says I need to keep shading columns until I get to 69 squares. So here would be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. About half. 33, 36, 39. Then I have 42, 45, 48, 51, 54, 57, 60, 63, 66, 69. Here we go, right up to here. Kind of show that whole section because it did say draw or outline a rectangle, so I'm trying to do that. Oh, it's pretty. Oh, it did say shade, so if I were to shade, see, there's 3, 6, 9, 12, 15, 18, 39, 42, 45, 54, 63, 66, 69. That looks good. The question is, how many groups of 3 can you make? Oh, I need to actually count the groups. You see here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I count 23 groups of 3. Okay, so did we follow through what was asked of us? We did. Now it says think of 69 as 60 plus 9. Okay, I can think of 69 as 60 plus 9. They broke it apart. Now to ask here, it says break apart the model into 2 rectangles to show 60, or the sum of 60 and 9, that's how we say that, divided by 3. Label and shade the smaller rectangles. Use 2 different colors. So the diagram just below does show the 2 different colors and how they've labeled the rectangle. So I'm going to go ahead and actually shade in then all of these little squares. This will be the smaller rectangle. Do all but 3, 1, 2, 3. So it's going to come on right up to here. Okay, now I've shaded them in. I'm going to go ahead and label. This was my column. My columns were 3 high, and I had 20 going across here. And then of course I have this smaller rectangle, two smaller rectangles in that one large rectangle, and then I have 3, just like the drawing down below. Now what's so significant about that? Why is that so important here that we've done this? Well, it says that each rectangle here, it actually models a division, because if you recall, up above, it stated the distributive property of division says that dividing a sum by a number. So here we have a sum, 60 and 9. That's a sum, because if you add those together, we get 69. That if we were to divide a sum by a number, and of course our number is going to be 3, so we're dividing it by a number, is the same as dividing each add-in by the number and then adding the quotients. So this is what we're doing right here. So this here is modeling the distributive property. And I want to make sure, because this is our focus in this lesson, the distributive property is being used here. Okay? Woohoo! Let's see. So 69 divided by 3 then is the same thing as saying 60 divided by 3 plus, because we're going to add those quotients at the end, as 9 divided by 3. And this is a great way to break them apart, because both 60 and 9 are divisible by 3. What does that mean? It means that 3 will go into 60 without getting a remainder, and 3 will go into 9 without getting a remainder. Now we just look at it and we say, oh, what's 60 divided by 3? 20, right? Because 6 divided by 3 is 2, and then you have that 1 power 10. And 20 times 3 will get us right back to 60. Now we move on to 9 divided by 3 is just 3. So now it did say that we need to add the quotients. Well, 20 plus 3 equals 23, which is what we got up above. That was how many groups of 3 we had, 23. So therefore the inverse operation, this is that undoing, doing the opposite. That would mean then at 23, right, times 3 is going to get us back to 69. How cool. That is pretty cool, because we basically created like a little area model. That's what we did. We used a grid to look at this area model so that we could actually see what's happening. Let's see what's down here at D. D says outline another model to show 68 divided by 4. How many groups of 4 can you make? Okay, so there's my rectangle. I have my 68 little centimeter cubes like inside on my grid paper, that is. The columns of 4. The question is, how many did I have across? So how many groups of 4 did I make? Let me see here. We'll count them. We'll do them out here. We have 1. So I count 17. Does that seem reasonable? I suppose. 4 times 7, that's 28. That'll give me the 8 at the end. So more than likely. So how many groups of 4? 17. Think of 68 as 40 plus 28. I could do that. Break apart the model, label, and shade to show 2 divisions. Just like the one up above. Kind of same thing. Now again, 40 is a multiple of 4. 28 is a multiple of 4. And a multiple is just like when you skip count. 4, 8, 12. And the reason why it's important saying it's a multiple of 4, meaning that 4 will go into that number and we won't get a remainder. And that's a good thing. So that's why we want that. So we're going to need one smaller rectangle that's going to have 40. Well, 4 times 10 is 40, so it actually would need 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to mark it right here. Okay, so there's my 2 smaller rectangles. That means that I have 4 times 10 here. If you wanted to think there's 40, and then I'm going to have 4 times 7 here, which is going to give me my 28. I'm thinking multiplication. We are dividing, but we're thinking of breaking that one larger rectangle into 2. There's my first shaded rectangle. So I had a column of 4. My 10, because remember we broke that apart, and then over here I would have 7. So 4 times 10 is the 40, and then my 4 times the 7 is the 28 that fits in here. So we were thinking of 68 as 40 plus 28, which we could say that those are like 2 add-ins for 68. We broke the model apart, we labeled it, and now we need to show, and we shaded to show those 2 divisions. And so because we're thinking of it as 40 and 28, that's what's going to go here. 40 and then 28, because we were going to take 40 divided by 4, and we're going to do 28 divided by 4. And 40 divided by 4 is going to give us 10. And then of course 28 divided by 4 will give us 7. And then as above, it stated we add these 2 quotients. and the two quotients added together gives us 17. Wow, this is really cool. I like this. Yeah, it's like looking at what we're doing, but by using the area model, it's helping us get a picture of what's happening in the problem. And that's so important. Okay, let's move on. Now it says draw conclusions. Okay, looks like we're going to have some writing to do now. Now it says explain how each small rectangle models a quotient and a product in step C. Well, we need to go back to step C. And step C, was that example of where each rectangle models a division, and then we had the 69 divided by 3, and we broke 69 apart with 60 plus 9. Those two division problems got ourselves two quotients, and then we added those quotients. So now we come back here, explain how each small rectangle models a quotient and a product in step C. Well, I would say the first small triangle represented, because it says we have to model it as a quotient and a product. So the first small, the first small represented the product 20 times 3 equals 60. Now because of and I used this earlier in the video, I use the inverse operation, but this inverse relationship between the two. Multiplication and division, between multiplication, and I'm just going to put slash division. Want to think of that one, I want to sink that word and in there, that would be cool. And the smaller of the two rectangles, the smaller rectangle models, and we had both because we had 3 times 3, so we had 3 times 3 equals 9, but also the division. So I'm just going to put a semicolon here. 9 divided by 3 equals 3. Explain how each small triangle models a quotient and a product in step C. And we did do that. The first rectangle represented the product 20 times 3 equals 60. That's true. That's the product. And then because of the inverse relationship between multiplication and division, it could also be represented as division. 60 divided by 3 equals 2. It's a really important concept to see how they're connected. Now it says compare your answer in step A to the final quotient in step C. What can you conclude? Whew, great question. Let me take a look. So let's look at that at step A here. We took 69 divided by 3. We made a column of 3 until we reached 69, which we determined was 23. Okay. When we come down to C, you can see that we still have our 69 divided by 3, but we broke them up into parts. 60 plus 9, and then we did the division. And we still got 23. First, I would say they're the same. We can conclude they are the same. Okay, so they both had the answer of 23. What it shows that you can break apart the dividend, okay, the number that we're trying to divide, the dividend, and still get the same quotient. Okay, woohoo! This is so very cool. The distributive property. Now it says we're going to think smarter, but we don't usually always get that. I like that. I like to think smarter. Now it says to find the quotient 91 divided by 7, would you break up the dividend into 90 plus 1 or 70 plus 21? Explain. Okay, so we have this. We're trying to find the quotient of this division problem. Remember our 91, he's our dividend. That's the number that we're trying to divide. Here is called our divisor. And the divisor, remember, decides whether, like, how many groups that we can make or how many are in each group. Okay, and then it says if you were to break that dividend up, should we go with a 90 plus 1 or should we go with a 70 plus 21? Explain. Well, what stood out to me right away was the fact that 70 and 21, both of those numbers, they are divisible by 7. And when I say divisible, I know I'm probably using a 5th grade word. I know, I'm not sure. But I would just say it just means you can divide it without getting a remainder. Because 7 times 10 would give you 70. And 7 times 3 would get you 21. So we want to be able to choose the two add-ins that are going to make it so that we can divide it by 7 evenly. Okay, without any remainder. So I'm going to choose 70 plus 21. And it does say I have to explain. So I have to follow it. It does say explain. And I'm choosing that is because we need to break the dividend into, because we're breaking it apart. Remember, we broke it up into two add-ins. So we need to break the dividend in two numbers that can, let's say that can be easily divided by 7. I kind of explained that already, so we'll go ahead and move down. Now we have make connections. We have the purple hands again, so it's still a hands-on. So let's take a look at this. It says you can also model 68 divided by 4 using base 10 blocks. Okay, very cool. Step 1, we'll first do is we'll go ahead and model 68. And I can see that here. Look, I see 3 10s here, another 3 10s here. That makes 6 10s, or 60. And I see 5 and then 3. And 5 plus 3, just so you know, is 8. So I can see where my 8's coming from. 68 then would be equal to, two add-ins, right? I'm going to have 60 plus 8. Could this be any easier? I don't know. I don't think so. Maybe, but probably not. Now, so step 2 says divide the longs, well, that's what they call those longs, into 4 equal groups. 4 longs divide into 4 equal groups with 2 longs left. Regroup 2 longs as 20 small cubes, divide them evenly among the 4 groups. Okay, that was a lot there. Let's go ahead and take a look at that. So just looking at the longs, we're going to divide the longs into 4 equal groups, and I can see 1, 2, 3, 4. I see 4 groups. Okay, cool. There were 4. But it also says it says 4 longs divide into 4 equal groups with 2 longs left over, right? Because if we went up above here and just kind of crossed out, there's 1, 2, 3, 4. They were used here, but we still have these 2 left over. So then it's saying regroup those 2 longs as 20 small cubes, because we have 10 and then another 10. Okay, and when we do that, when we break those apart into 20 small cubes, you can see that they'll divide evenly among the 4 groups. Okay, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You get the idea. We end up with 20 of those cubes that we just broke apart. So that took care of all these longs right here. Okay, are you good with that? I hope so. Now it says 60 then, because that's how much that was. 60 divided by those 4 groups then means that we have what inside? 15. Oh, I knew you guys knew that. Oops, that was kind of a sloppy. Ooh, I didn't like that. 15. There we go. You are not the chosen number. Okay. Step 3 says divide the 8 small cubes into the 4 equal groups. Okay, because we had 8 of them. If you look up above, yeah. So 2 will go into each group, and that gives us our 8 divided by 4 equals 2. So now it says, 68 divided by 4 equals 60 divided by 4 plus 8 divided by 4, which is going to equal 60 divided by 4, which we determined was 15, and then 8 divided by 4, which we determined was 2. 15 plus 2, 17. Okay, now we're not really supposed to be focusing so much in this lesson on the algorithm, but I can't help but want to double check my work. So if I were to take my 17 and do the algorithm, nothing wrong with seeing how it works. Just remember, this isn't the only important thing in math. All right, Common Core says we have to understand what we're doing, but 7 times 4 is 28. So I just put my 8 down here and I carried my 2 up into the 10s. The main reason why I carry that number is place value. That's the main reason, to make sure it ends up in the right column. Now I have 4 times 1, which is 4 plus 2, which is 6. And you can see it is 68. It does work out. So what we were really focusing on was how the distributive property could be used, right, to divide a number and break that dividend into 2 numbers, 60 and 8. And that when we divide and make those 2 divisions, because we have 1 division here, we have a 2nd division here. And then when we add those quotients, look at, we still get 17. I mean, we get the correct answer. Whether we went straight to 68 divided by 4 or the 60 divided by 4, that's why they have this all together. Okay, I know, what am I hearing music in the background? I'm like, what is that? Yes, you know what? It's my sound crew. Yes, my imaginary sound crew. They're letting me know that the video's coming to an end. Hey, thanks guys. Okay, so that said, my friend, you know, I used to get really, really sad, you know, at the end of the video. But you know what? I'm going to keep it positive today. That's right. No tears. I'm going to put the Kleenex away. I am going to simply say, don't fear. Underdog is here. No, actually, Mr. War is here, and I'm going to tell you there's another video coming very soon. It's going to be lesson 4.7. Now, until then, live long and prosper.